Welcome, this is to introduce our latest paper on data association using innovation projections for landmark-based localization. And I've worked on this research with Dr. Ali Hassani over the past 5 years or more. And this is about augmenting GNSS to provide resilient navigation. We'll use LiDAR, LiDAR only, and it is for transportation applications, so we're going to consider safety risks. We'll focus on one particular source of navigation error, which is incorrect associations. And that occurs when you use features extracted from your LiDAR point cloud. And when you look at two tree trunks, they don't come with an identification number. So you need to correctly associate them. You need to find the correct correspondence between the landmarks that you see and those in your map. If you make a mistake, it causes positioning error and eventually safety risk. So we are going to qualify and bound the risk of the vehicle position or LiDAR position being outside of a safety volume when we think that it is inside. To do this, we use innovation projections as opposed to conventional methods that use innovation norms. Innovations for a Kalman filter is the difference between the measurements and a predicted version of the measurements. So we'll see that using this new method, we are not only going to reduce the risk of wrong association, but we are going to tighten the bound on our prediction of that risk, which is very valuable. And so the paper is going to take us through simple examples to help us understand what innovations projection do for us. And so we're going to consider a one-dimensional problem here where the LiDAR is at a location X, and we have measurements Z1, Z2, Z3 to landmarks A, B, C, and we need to find the correct association 1, 2, 3, A, B, C. And we can consider all possible permutations, all possible ways we can make a mistake in this process. When we look at our prediction of those innovations in a three-dimensional innovation space, so it's 3D because we have three measurements, we will see that the mistakes that we make, those incorrect associations, they're going to have an impact on the mean innovation vectors that is very structured and very predictable. In fact, those incorrect mean innovation vectors, they lay in a subspace of the innovation space. Even more than that, this is where our student Jonathan Baker came in. Those mean innovation vectors, they form a convex polytope, so that by taking projections on a line between the origin of the innovation space and the centroid of that polytope, we can get very effective correct association criterion and bounds on the risk of wrong association. Okay, we experimented with this on a cool data set from our friend at Illinois Tech, Matt Spenko. It's a nice data set because it extracts tree trunks and landmarks, both in areas where they are sparse and other areas where they are cluttered, where the risk of incorrect association is going to increase. And we look at the integrity risk, so the details are in the paper, and we get a bound on the integrity risk for the old method, the innovations norms method, the conventional method, that is much higher, orders of magnitude higher than using innovation projections. So I hope you enjoy reading the paper, and thank you for your attention.